Okay, so today we're going to be talking about vectors and solving for sides or angles using law of sines, law of cosines. So we're going to be drawing a lot of diagrams to go with these, so make sure that you have your packet and your pencil out and available to you. All right, so the first example says we have a tractor stuck in the mud being pulled. I am just all over the place today, aren't I, guys? Out of the mud. One truck applies a force of 1,200 pounds, and the other truck applies a force of 1,700 pounds. The angle between the two forces applied by the two trucks is 72 degrees. Find the magnitude of the resultant force to the nearest pound. Okay, so here's our tractor. Okay, it looks like a tractor, right? You've got one truck that is pulling in this direction, we can say, and with a magnitude of 1,700 pounds. Okay? Are you okay with that? Yes or no? Okay. The other truck is pulling with a magnitude of 1,200 pounds, and the angle between them, between the two forces, is 72 degrees. So let's say we're being pulled this way. This is 1,200 pounds, and the angle between is 72. Does that make sense to you guys? Okay. We want to find the magnitude of the resultant force. What's my resultant force? How do I find it? Do you see it there? What do we need to do? We need to make a parallelogram. Remember, we said vectors, resultant forces, parallelograms, right? So we need to create a parallelogram. Fine. That's pretty simple, right? We know opposite sides are parallel. Here's my parallelogram. That looks like an awful parallelogram. But what's a resultant? Where do I find it? Where do I find the resultant? From one angle to the other. Where? From which way? It matters, huh? Okay. Good. Here's my resultant. Okay. Between the two forces that we specified, right? Okay, good. So we know some stuff about parallelograms, don't we? What do we know about their sides? Opposite sides are congruent. So I know this is 1,700 and I know this is 1,200. Are you okay with that? All right, what do we know about their angles? Well, can I use alternate interior based on the information I have? Okay, does the diagonal of a parallelogram bisect the angle? No. Okay, so we can't use that. We know that this other full portion is going to be 72. We know that, right? But what about the other angles? Say it again. Supplementary. What does supplementary mean? They add up to be 180. So how can I get this angle here and this angle here? Okay. Please tell me what you get. I'm not doing it for you. Huh? Thank you. So that's 108 degrees. Are we okay with that? Okay. All right, so what is it that I'm looking for? Give me the word before resultant. Magnitude. What does magnitude mean? What? Be a little more specific. What about the force? Strength or the size. Okay, the strength or the size of the force. So I'm looking for it in terms of what kind of units? pounds. Okay, so I'm looking for this right here. Are we okay with that? Make sure you label it with something. All right, so I need to figure out what I can use to find the resultant force, the magnitude of the resultant force. So what do I have available to me? I have two sides in the angle. Where's the angle? Give me the word for in between, please. We do say it all the time. Two sides and the what kind of angle? No. Included. Thank you. Okay, two sides in the included angle. Okay, so we've got two sides in the included angle, and I'm looking for the side. Where's the side in reference to that included angle? Across? Don't give me across. Give me the other word. Opposite. Okay, so two sides, included angle, looking for the side opposite the included angle. What do I use? Law of cosines. Beautiful. Go ahead. I want you to set up law of cosines. Find me the magnitude of my resultant in proper units. And then when you get it, check with me. Okay, somebody tell me what's right. Okay, I'm going to do x squared equals. Yeah, and why do we use 108 instead of 72, guys? It's the included angle, okay? Am I going to do out all the algebra? No, why? Calculator's going to handle that for me. I'm simply going to do what? Take the square root of both sides, okay? Now, two things you have to be careful of. One, that you're pressing the correct buttons, okay? I saw about 3 of you out of the 11 of you that are here, okay, type in the wrong thing. You have to be cautious of that. What else do you have to make sure you check on? Make sure you're in degrees. Okay, that's important. Good, so what did we get? Yeah, X is approximately 2,364 pounds. How many people got this? Nice job, guys. Okay, you ready to try another one? So guys, this really isn't too much different from what we've been doing. It's law of sines, it's law of cosines. It's just now taking and drawing a picture with it, okay? Which we did last time anyways with our applications. Okay. Oh, hello. Is that right? Why is it labeled number 4? Do we know? We don't know. I just got fancy. Pat myself on the back for that one. Okay, so the measure of the angles between the resultant and two applied forces are 65 degrees and 42 degrees. And the magnitude of the resultant is 24 pounds. Find to the nearest pound the magnitude of the larger force. So the first thing you're automatically going to do is what? Draw a parallelogram. Absolutely, draw a parallelogram. And with the parallelogram, you should have what in the center? Speak up. The resultant. Okay, so what do we know? What has it already given us to start? It's giving us the angles, yeah, 65 and 42. Where are we going to put those? I got you. So this is going to be 65, and this is going to be, okay, good. Okay. It says the angles on either side of the resultant, right? And that resultant is your diagonal. What is it? What do we know about the resultant? It's 24 pounds. Good. So we're going to put that in there too. Okay, so that's all of the information they gave us, right? But there's a lot more information we can get. Agreed? All right, what do we know? Now, Amber said something earlier, and I said not yet. What were you talking about? Has to do with angles. Alternate interior angles, right? So we can use that now. We know with the parallelogram or parallel lines, we have alternate interior angles. So up here is going to be what? Yeah. And here? Good. Okay, so we have a little more information. What else can we gather? The third angle. Good. How am I going to get it? Good. So we're going to find this angle because we know they're supplementary. So we can do 180 minus 65 minus 42. I'm sorry? 73? Okay, great. We got some more information. What are we looking for? The magnitude of the larger force. How do I know which one's the larger force? How? I know by looking at which one it is, but how do you guys know? Opposite the larger angle. Good. Which one's my larger angle? 65. So opposite my larger angle, we'll call it x. Okay, larger side is always opposite the larger angle. Okay, so x is what I'm looking for. How can I find it? Law of sines. Why? Good. I have an angle and its opposite side. I have an angle. I want its opposite side. Okay. Good. Go ahead. Find me my magnitude of my larger force, please. Okay, who wants to walk me through setting it up? Not everybody at once is overwhelming. Okay. Awesome. How many of you set it up that way? Stephen, how'd you set it up? How did you set yours up? You put the signs on top. Is that okay? Sure, absolutely. All right, now what? Sure. So 24 times sine of 65 equals x times sine of 73. Okie dokie. Divided by sine of 73. And we put that in our calculator, and we get x to be approximately, what? 23 pounds. Can I have a second? We agree? Good. What do you think? Is it any different from what we've been doing? No, it's just now drawing a parallelogram and figuring out where things are, right? We doing okay? Okay. No crying yet, so we're doing well. All right, so let's try another one. All right, I want you to read it. I want you to set up the picture, get your answer, and we'll go over it. Okay, so see if you can do this one on your own. So, first thing that I did was I drew a parallelogram, right? With the resultant. My parallelograms always look exactly the same. Do they always have to look exactly the same? No, mine just do. I don't know why. Two forces act on a body. Here's my two forces, right? They're acting on a body. Here's the body. That produced a resultant of 70. Where's that? The diagonal, so 70 pounds, right? One force is 50. I'm going to make it the smaller one. And it forms an angle of 67 degrees 40 minutes with the resultant force. So here's the resultant force, here's your other force. The angle has to be in between them. Okay? 67 degrees 40 minutes. Does it make you uncomfortable that it's in degrees, minutes, seconds? Suck it up. Get used to it, okay? It's okay to be in degrees, minutes, seconds. You're going to see it. Like I said, boat navigation, planes, all of that stuff is going to be in degrees, minutes, seconds. It's not going away for pre-calc. We're going to use it then too, okay? So we want the other force. Notice I selected the top instead of the bottom. Why? I have all the information I want for the top triangle. Why mess with the bottom one if I don't need to? It's just going to make more work for me. I don't want more work, okay? I want less. So how do I set this up? What am I going to use? Law of cosines. Tell me what to write, please. Good. And what do I have to do? Take the square root, right? So I'm going to go back here, and I'm going to put in exactly what I see, okay? 50 squared plus 70 squared minus 2 times 50 times 70 times cosine of, where do I find it? in the template key. Okay, degrees, minutes, seconds. And we've got 67 degrees, 40 minutes, and how many seconds? Sure. In the math template key next to the 9. Okay. 68.8, which, rounded to the nearest pound, 69 pounds. How are we feeling with that? Okay. You have 8 problems for homework tonight, guys. I want them done. They are all basically review for this unit. Okay, it's all law of sines, law of cosines. We will review for the test tomorrow. Your test will be Wednesday, Thursday. You all need to do well on this test. We need to boost these third quarter grades, guys. Okay?